Hello everyone and welcome back. In this video we're gonna go over our controllers, our input and output, so stick around for that. Alright, so we went over the timer with the previous video and we already know our RAM, so the last thing you need to know about our PIA, peripheral interface adapter, is our 2-bit parallel port for our input and output. So let's go over, and that's gonna be our parts is responsible for reading our controllers. So right over here, you notice we have port A and port B. Port A is handled from the software, as is described over here, and port B is a console switches, which is only a read-only option. You can write on them, unlike the port A. So here we have our switches, and here's our hex address. So it's input by the hardware. And here we have our bits order. So 0 is game reset. D1 is select. There's no use for D2. D3 is black and white. So if it's 0, it's black and white, 1 is color, and pretty much if it's 0, it's pressed. Otherwise, it's not pressed. And of course, I have the 6 difficulty and the 7 the same thing. I know that later models they removed the difficulty, so I don't think many games use this anymore. It's pretty much most games use game select and game reset. So let me show you guys the picture of the console switches so we can have a clear picture. So here I have a picture of our Atari system. Let me zoom this out. And the switches for console B are the switches that we press over here. Here's the power, the black and white, the difficulty for the left or right, game select and game reset, just so you guys can have a mental picture about this. And now let me show you guys the back where is port A is located. And here, right over here, you have the controllers. That's where port A is located. So that's where port B being the top over here, and top A being the bottom over here. That's our pins over here. They're located. So now let's go back to the Stella manual. So been over port B, which is read only, and port A. And part of port A that we need to know is the data direction register, DDR. And it's pretty much saying that in this register over here, which is where the hex 281, we have it's a 1 byte. I mean, it contains 8 bit, and the first 4 is for player 0. I mean, the first 4 is player, no 0, it's player 1. Player 0 is the last 4. So this is 7th and this is 0. And what it's pretty much telling us is that from 0 to 7, if you write 0 on it, it means it's an input. If you write 1 on this DDR, it means an output. So you're giving an output to the controller, and if it's 1, no, I'm kind of lost. Okay, 0 is an input. So if it has 1 as output and 0 is the input, and you want to input whenever you're going to use the controllers. So just keep that in mind. And it says right here 4564, that be outputs, will be for inputs. Right over here. So why is this part is for player 0 and this is for player 1? And if you come over here under joysticks controllers, which is the most used, here you have from the byte 7 to 4, that's a player 0, and 3 to 0, that's player 1. So that's corresponding to the same thing. And let's go over the controller. And here we have this register, switch A. So the switch A, and this is the switch DDR. But just they look alike, but there's a bit different. And here on switch A, so from 0 to 3, that's player 1, and from 4 to 7, that's player 0. And that's, as you see over here, is the direction. So if I were to move my joystick up from player 0, D4 is going to be triggered, and 0 indicates the joystick is being moved, and 1 that means that it's not moving. So that's how we're gonna work with the joystick. And if you press the action, the red button, that's port 4 for player. Well, let's go over here. Port 4 for player 0, read input trigger, and port 5 it's input 4, input 5 on the same same port. That's input 4 and input 5, not different ports. So that's how that's how the joystick works. Now we have a paddle, and the paddles works from input 0 to 3, and as you over here have different bytes over here. The paddle can be written to the swatch card according to the following tables, and so forth. But I do have the link over here on this Spicewire has also his own demo over here how this paddle works, and it's pretty much it's like a discharge on a capacitor, and we're gonna measure the difference and so forth. But using the paddle is a bit of a problem, since it has from the angle 0 to 330, and that may take quite a few, at least 2 frames per second. That's for at least 2 frames over renderings, so it's not really used much. That's why you don't see a lot of games using the paddles, and when they are, there's like games like Breakout and so forth. But I'm not gonna go over it pretty much. I know that I have to load a where is it? Let me go over here. We have to load our timer over here. Oh, here it is actually. Our timer input, and have to measure our paddle with our, see if it was discharged. If you can go through over here to the with this example and so forth. And of course, if we go over here, we have our keyboard controllers, and like it says 12 buttons from 4 rows in 3 columns. And here's our columns for player 0 or for player 1. So we actually have to do double checking. So you're gonna check the column over here. For example, check input 0. From input 0, you're gonna check, for example, from player 0, I'm gonna check either which one is the column. Is this I'm assuming let's see, the top button was pressed, so it's this one on the first column, on the second column, so forth. So let me show you guys with a picture, just to be a little more clear with this. Alright, so here's our controller. Let me bring the throttle over here, and let's separate. So here's our first column. That's our, oh damn, this is awful. Okay, this is our first column. That's our, let me put here by some color. That's our input 0 right over here, represents color red. And here, if I can drag it over here, let's switch colors to use have the other colors, the other input numbers. Oops. Okay, so now we have input input 1, I believe. It's a bit hard to see. Let me move over to the controller. Here it is. And let's do green as the last one. And that's our input 4, if I'm corrected. Here it is. That's our input 4. So here it is, each one of our columns. And now let me use this blue color over here just to go over. And now that we have our columns, so first I'm going to check the column the I'm gonna load this value over here or something like that, or we're gonna mask it we're gonna load our masking value, and then I'm gonna do a bit comparison. I'm gonna go over pretty fast with that, and then we're gonna set from player 1, from player 0, my bad, from player 0 I'm looking at the bytes from 0. Let me put here a byte. Let me separate this. 1, 2. Okay, that's fine. 1, 2, 3, 4, 5, 6, 7, 8. There you go. Okay. So if I'm player, let me separate this. If I'm player 0, I'm over here on this side over here. Let me. Is there any other color? Let me put black. Let me draw over here. Here I'm player 0. I'm player 1. And if I press, for example, if this is input 0, so D4 over here, so this is 0, 1, 2, 3, 4, 5, 6, 7. So let me bring the color back over here. Let me just select blue now. So for example, if I press 1, in our input 0, which is going to be our byte over here, if I press 1, it's the one at the top, so D4 should be set to 1, and everything else should be 0. So that's pretty much a visual representation how it works. So the top is this one. If it's input, let me actually put this over here, 1 right over here. If it's input 1, like if I'm pressing 2, so this is going to be over here. And if I mask of input 4, it's going to be over here. So the first one is corresponding to here, and inversely, the first one for player 1 is over here. So for example, now if I press the number 7 over here, it should be over here. And if the other player press the pound number sign, whatever that's called now, that should be over here. So this is input 4, this is input 1. I'm gonna do a bit of a masking, and that's how the keyboard controller works. So now let's step into the code. Alright, so let's get you the code, and let me just copy this and put it over here, and we're gonna change this to a value, let's say 72. Let me take my caps lock out. Okay, so now let's just put the code first, and I go over it as I go. So load A with our bit value that I want, and if you heard joystick controller, it's the same thing from all of them. So I'm just gonna show you. I'll show you guys that one too, but let's start with this one. If I press the up key, since I'm player 0, I don't know what my player 1 inputs are, but for this Tele emulator, but I know if I press up on my keyboard is equivalent to joystick controller up. So I'm gonna press S. Let me come over here. Disassemble. Oh no, debug. Input. Where is it? Player 0. See, my actions for up on my keyboard. It's the same thing as up on my joystick, and that's what I'm wanna do. So that's on D4 or byte 4 from 0 to 7. So 1, 2, 3. It's the far off one. 1, 2, 3, 4. So the same thing as this is this. So that's our masking, and I'll go over it as soon as I run the emulator over here. And I'm gonna do a bit comparison with our switch port A over here. Switch A. So that's our comparison. A bit operator is pretty much just doing an AND comparison. But if you do an AND, you change the value of your accumulator register. However, a bit just change the processor status flag register, should I say, or the flag register. Some people call it either or. So I'm doing a bit over here, and then I'm gonna branch equals 0. Let's say up, because I pressed the up button. Oh, not here. Let's go over here, press up, and here my Y value. I'm gonna start a Y value into my column luminosity background. And if I don't press up, I just want to skip the code below, and I use this code. I explain this code on the skip draw. Always this you see is a bit opcode. However, it takes a two more values since it's a full address, and store Y, that's an opcode, and column background is another byte. So this takes 2 bytes over here following this. So think of this as this. So these 2 values go over here, and we skip this. Like I said, I went through this before the skip draw, so it should be fresh in my memory. So all we're doing over here, if I press up, it's going to change the color of our background. So let me run, see if it works. Let me press up, and here is how it works. So let me close this and run one more time and go to the debug to show you guys what we have going on over here. So here, let's run current line over here. Step. Let's bring our input and output. So here is our read, or swatch read. And what we're gonna do over here is see everything's set up to 1. Let me step over here to load 10 on our accumulator. And 10 is the exact same as this. 00001, which is the exact same. Let me come over here. I'm going to set manual to up. So that's our masking value. And then I'm going to do a bit first swatch right over here, which everything is 1. So if everything is 1 and just this is 1 over here, nothing's going to get zeroed out because we're doing an AND comparison. An AND, both of the values that should be 1 and 1 to actually, after the comparison is done, it should be 1. Meaning, if you remember from the 6502 videos, I think I gave an example like if you have a kid and you tell him if you want to eat this candy, you either can, not either, you have to clean your room and do your homework, something like that. So in order to him to get the candy, which is to, for example, to turn the 0 into 1, he has to do both, clean the room and do the homework. Then it turns to 1. If you do one or the other, it's never going to change the 0 to 1. And if he does neither, never is going to change this 0 to 1. So that's pretty much what he's doing over here. So since everything here is a 0, a 1, and a bunch of zeros, comparing to this one, so this one over here is going to change this one over here, and it's never going to be zeros because this is branch equals 0. So over here it's going to come, see, then it's going to skip, and so forth. Now let's run the line over here. Let's set our joystick to up. So it's going to change over here. Step. Here we go. So now, where is the load 10? Here it is. This one that's missing over here is right over here. So everything is going to be zeroed out. So now we're going to get a 0 over here. So we do get a 0. So branch to this part over here. Change the color. And that's how we get our controllers right over here. So if you want to do the same thing for switch, let's say game reset, the 0 over here. Let's do this. Let's just set it to 1. I think it's the same thing. So if I press the reset over here, I don't know what's, I don't know what's set up on. Let me check over here. F1 or F2. Okay. Exit menu. Let me F2. There we go. So as you see, it's the same thing as a press up. I'm pressing F2 right now, and it changed everything. And of course, oh, sorry for that. We can pile up a bunch of them, masking with our port versions, sort of B or A, and so forth. And we're gonna just go over there or then exit over here or something. But that's pretty much how our input and output controller works. And let's go over here. So this is our switch A. Here's our GDR for input and output. The DRB is hardwired. It's always going to be a always going to be an input. And here we have our timer output, read only. This is for a paddle. And here is our timer. So we pretty much cover all of this part. Like I said, the only thing I didn't cover is the paddle. It is like, well, here you have 4 paddles, but you see 0 to 3. It can be a bit complicated, like I said. I know if you went to the 8-bit workshop book, he goes over this as well. And also, here I was gonna show you guys this bitwise calculator over here. And here, of course, I have the samples over here, how it works and so forth. I'm gonna put all the description over here. And that's it for this video. And see you guys in the next one. I'll probably be covering the collision system. And like I said, that's it. And thanks for watching. See you guys.